Hi guys, so welcome to our YouTube channel.
So we are making a video assignment for our physics subject. The code physics is PHY110. So this is our member.
So I'm Nur Ada Balkis binti Roslan.
And I'm Nur Ashikin binti Muhammad.
I am Nur Alisa Fatin binti Ramli.
So enjoy the video.
A rock is dropped from the edge of a 800-meter cliff. How long does it take to hit ground?
A rock is dropped from the edge of a 800-meter cliff. How long does it take to hit ground? So first of all, we must to draw the diagram to be more understand about this question. So this is a cliff. So this is dy or sy, which is displacement for vertical component y, or equal to h. So the question said that 800-meter cliff. So 800 show that the height. So the sy equal to 800 meters. So the ball is dropped from here to here. So uy equal to 0 because the first speed is 0. The initial speed is 0. So the question asks about how long does it take to hit ground. So it's meaning that we must use time to find the how long. So how long is show time. So we must use the question sy equal to uyt plus 1/2 ay t square. So sy equal to 800. So uy equal to 0 times t plus 1/2 9.81. T square we want to find. So t here we want to find. So we must use the gravity acceleration as a positive because it's going down. If they are opposite the gravity, we must to use negative. So 800 equal to 0 times t equal to 0 plus 4.9 t square. So t square equal to 800 divided by 4.9. T square equal to 163.26. So t equal to 163.26 set because we want to the power. So the answer is 12.77 seconds. So the time taken for the ball to reach the ground is 12.77 seconds. Okay.
A diver 3.0 meter per second dives out horizontally from the edge of a vertical cliff and 4.0 seconds later reached the water below. How high was the cliff?
So the question 2 is a diver 3.0 meter per second dives out horizontally from the edge of a vertical cliff and 4.0 seconds later reaches the water below. How high was the cliff? First, we need to sketch the diagram first to understand what the question wants. Okay, first, okay, so this is the diver and this is the water. So first we need to identify the information that has been given in the question. So we can identify that the information that has been given is speed, which is speed is Vx equal to 3.0 meter per second. It is because it is horizontally. So the next is the time that has been given is 4.0 second. And the question is how high was the cliff. So we can know that the question that has been, so the question want the height, which is the component y. So this is mean that it wants hash. Hash also can be identified as sy, which is displacement. So proceed to the next. We need to, so we use this formula, which is sy equal to ut plus 1/2 at square. So we want to know about the sy, which is the displacement of y. So the initial speed is 0 because it did not move. So the time given is 4.0 plus 1/2, acceleration 9.81, and the time 4.0 square. So this is equal to 0 plus 78.4, and then the last answer is 738.4 me. Oops, I'm sorry. So the last answer is 78.4 meter. So the height is 78.4, or the sy, which is the displacement of y. So thank you.
A ball thrown at 35 meters per second from the roof of a building lands 40 meters from the base of the building. How high is the building?
The third question is a ball thrown at 35 meters per second from the roof of a building lands 40 meters from the base of the building. How high is the building? So we have sketched the situation of the questions. This is the ball. This is the displacement of vertical, and we want to find height. Height also known as dy, displacement of component y. So from the question, we know that the speed for component x vertical is 35 meters per second. The displacement for the component x is 40 meters. So now we want to find the dy, displacement of component y. But we do not know the time, because first we want to find the dy, we have to use this formula, 4.9 t square. So we must find the time first. To find the time, we use this formula, displacement of component x equal to speed multiplied with time. So we know that the displacement of component x is 40. 40 equal to speed of component x 35 multiplied with t. We want to know. So t is equal 40 over 35. After we calculate it, we got t equal to 1.143 second. So we have find the t. We can calculate the dy. After we get the t, we can know to calculate the dy. Dy which is same with height. So dy equal to 4.9 multiply with the time 1.14t square. After calculate it, we get 6.40 meter. So the height is 6.40 meters.
A soccer ball is thrown horizontally from the roof of a building 45 meters tall and lands 40 meters from the base of the building. What was the ball's initial speed?
So the first question is, the soccer ball is thrown horizontally from the roof of a building 45 meters tall and lands 40 meters from the base of the building. And the question is, what was the ball initial speed? So first, draw the diagram. So this is the ball. At first, it throw the ball horizontally. So at first horizontally, and the last, it will drop to the ground. So it say that 45 meter tall. So tall, this equal to SY, which is displacement for component Y, 45 meter. So and it say that its length 40 meter from the base. So this is the place which is the ball is laid, and this is the base of the ball. So the distance is, we assume that SX, which is displacement for component X, equal to 40 meter. So we have SY equal to 45 meters. SX equal to 40 meter. So the question asks, what was the ball's initial speed? So we want to find the Vx, because the initial speed show the for vertical x, for the horizontal x, sorry. So first we must to find the time for the ball. So we must to use the equation Sy. So Sy equal to Uy times t plus 1/2 times Ay t square. So Sy we know 45. So Uy, the initial speed for Y is 0, because at first the ball did not move. So 0 times t. T we want to find. Plus 1/2 9.81, which is acceleration, gravitational acceleration. T we want to find. So 45 equal to 0. 45 equal to 0 plus the plus 4.9 t square. So t square equal to 45 over 4.9. T square equal to 9.818. So we must to remove the power. So t equal to 9.18. So t equal to 3.03 second. So after we find the time, we need to find Vx, which is initial speed for the horizontal, which is component x. Vx equal to Sx over 40. So Sx equal to 40. So the time here, we can use the time here. So the answer is 30.2 meter per second. So thank you.